At 2:47 a.m., checkout requests started failing with 500 errors. The error log showed deadlock found when trying to get lock on the order's database. The root cause? A federated table join that locked both the user's and order's databases, creating a distributed deadlock. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover database federation. Database federation partitions data by business domain into separate databases. Each database is independent, and the application layer handles cross-database coordination. This gives you independent scaling and clear ownership, but you lose the ability to join across databases in a single query. A single database works great until one hot table, like orders during Black Friday, consumes all IOPS. Queries on unrelated tables slow down. Federation breaks that coupling by giving each domain its own database and resources. The hardest part is deciding where to cut. Look at your query patterns. If two tables are joined in more than 80% of queries, they belong in the same domain. Also consider team ownership. Start with the domain that has the most independent traffic. Run this query on your performance schema to find tables that are frequently joined together. This helps you identify domain boundaries. Once you've split, you can't join across databases in SQL. Instead, fetch IDs from one database, then batch fetch related data from the other using an IN clause. This avoids n+1 queries. This Java example shows the batch fetch pattern. First fetch all orders, collect user IDs, then fetch all users in one query. This avoids n+1 queries. Distributed transactions across federated databases are a trap. They use two-phase commit, which is slow and can cause in-doubt transactions. Instead, use a saga pattern. Break the transaction into local transactions with compensating actions. This saga implementation reserves inventory in a local transaction, then creates the order. If the order fails, it releases the inventory as a compensating action. Federation means you give up strong consistency across domains. If a user updates their email, the order's database might show the old email for a few seconds. Denormalize data like email into the orders table at order creation time to avoid cross-database reads for historical accuracy. This SQL copies the user's email into the orders table at order creation time. Now the order has its own copy, immune to future changes. Federation multiplies your monitoring surface. Each database needs its own connection pool. Monitor cross-database query latency and set up alerts for pool exhaustion. Use distributed tracing to see where time is spent. Export metrics like connection usage and query latency per database. This helps you detect issues before they become critical. Federation is a last resort. If your database fits on a single server and query volume is under 10K QPS, you don't need it. Exhaust simpler options like query optimization, read replicas, caching, and vertical scaling first. This is the same issue we highlighted at the start. Here's exactly why that happened. The checkout service used a federated table to join the users and orders databases inside a single transaction. The join caused a lock on the user's table, which conflicted with a concurrent update, creating a distributed deadlock. The fix was to remove the federated table and replace the cross-database join with two separate queries. First, fetch user data from the user's database outside the transaction, then fetch orders from the order's database. The transaction now only touches the order's database. This is the exact mistake from the incident. A cross-database join inside a transaction holds locks on both databases, risking a distributed deadlock. Always fetch cross-database data before starting the transaction. Don't use a single connection pool for multiple federated databases. Each database should have its own pool with its own max connections. Otherwise, a slow query in one domain can exhaust the pool and block all domains. If you use an ORM with lazy loading across databases, each access triggers a separate query. A simple order listing page can generate thousands of queries. Disable lazy loading for cross-database associations and use explicit batch fetching. The article distinguishes federation from sharding, but a common confusion is that federation is a type of sharding, functional sharding. Emphasize that federation splits by domain, while horizontal sharding splits by key within a domain. This is crucial for interview questions. The article mentions sagas, but doesn't show how to handle failures reliably. Use the outbox pattern to ensure the compensating action is always executed, even if the service crashes after the first local transaction. The article warns against sharing a connection pool across federated databases. Reinforce that each database must have its own pool with separate max connections, and use connection pool monitoring per database to prevent cascading failures. When you see a lock wait timeout, check if the transaction spans multiple databases. Use show engine INNODB status to find transactions holding locks, then kill the offending transaction and refactor to single database transactions. Let's run through some common interview questions. What is database federation? Splitting a single logical DB into domain-specific DBs, app coordinates queries. How to handle transactions across federated DBs? Use saga pattern, not XA. When to choose federation over sharding? Federation for domain isolation, sharding for scaling a single table. And a few frequently asked questions. Can I use foreign keys across federated DBs? No, enforce an application code. How do I join across federated DBs? Fetch IDs, then batch fetch within clause. Is federation the same as sharding? No, federation splits by domain, sharding splits a table by key. To recap, database federation splits your data by business domain, giving you independent scaling and clear ownership. But avoid distributed transactions, denormalize frequently accessed data, and only federate when simpler options are exhausted. Ready to go deeper? Up next, NoSQL store types compared, then LSM trees and SS tables. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.